ጓደኞቼ ከዚህ በፊት እንግዲህ እስከ ኤክሰርሳይዝ 1.12 ድረስ አይተናል። ዛሬ Euclidean division algorithm ነው የምናየው። So today we see Euclidean division algorithm. Euclidean division algorithm says that as we now if for example, if a given number A divided by B, we have that when we get quotient Q, when we divide a number with B and we get Q, which is a quotient, and we have a remainder R. So this means that as we know, A is equal to the same as when we multiply B by Q, ማንኛውም ቁጥር A ለB ብናካፍል የምናገኘው Q የሆነ ቁጥር እና ያካፈልነው A ለB ስናካፍል የሚደርሰው አለ። ከዛ ደግሞ ቀሪ R አለ ማለት ነው። ከዛ ሲደመር R እናደርጋለን ማለት ነው። ስለዚህ እንደዚህ ነው። አንድ ኤግዛምፕል አይተን ብንሰራ በጣም ይቀለናል። ኤግዛምፕል እንስራ እስቲ። ለምሳሌ 7 ሁለተኛ ብንል 7 ለ2 ስናካፍል 3 ይደርስና ቀሪ ስንት አለ? ቀሪው ሪሜንደር ማለት ነው R 1 ይቀረናል ማለት ነው። ምክንያቱም 3 6 ቀሪው ደግሞ 1 ይቀራል ማለት ነው። ከዛ ምን እናደርጋለን? ለማረጋገጥ ብለን 7 ማለት እንልና B ታይምስ Q ማለት 3 የደረሰው ማለት ነው። 2 ሲባዛ 3 6 ከዛን ሲደመር ሪሜንደሩ R 7 እኩል ይሆናል 7 ይመጣል ማለት ነው። በዚህ መልኩ መስራት እንችላለን። So we do this example for quotient and this is the divisor, this is dividend. So 7 divided by 2, we get 3 and the remainder 1. Then we, as we say, P 2 times 3 B times Q. So we get 6 and the remainder is 1. So plus 1, which is 7 is equal to 7. So such type of theorem is known as division theorem. So we see the theorem in your textbook. Let us see the theorem. Let us see our theorem first. Here we have let A and B are two non-negative integers. They must be non-negative integer and B must be different from 0 because any number divided by 0 is undefined or it is not give meaning. Then there exists the unique non-negative integer Q and R, which Q is quotient and R is remainder. So A is the quotient times B, which is the divisor, and A is dividend and R is remainder. So as we know, remainder is less than P and greater than or equal to 0 or more than 0. So this is the theorem. This theorem is called division algorithm. We see this with example. In the theorem, A is called dividend and the Q is called quotient, B is called divisor, and R is called remainder. So here we can write the number like this: A over B, which is equal to, we get this implies that we A means A is a dividend, B is divisor, so A is equal to B times Q, which is a quotient. When we divide A by B, we get this, and R is a remainder of when we divide A by B. So this theorem is called division theorem. We see this with multiple example. If you are not understand, you can ask me with any time with comment of this video. Let us go some example. Write A in the form of B times Q plus R pair 0 less than or equal to R less than B. R must be less than B because the remainder is come when R is less than B and less greater than B. We can add to the equation. So let us see this example 47. Let us see this example 47. A is 47 and B is 7. We have to divide 47 over 7. We get that 6 times 7 is, which is 42. So Q is 6 and R is 6 times 7, which is 42. 47 minus 42, which is R is equal to 5. So we can write this equation. We get Q, we get R, so we can write this as A is equal to B times Q plus R. We can write like this. We have here 47. We can write this BQ is B times Q, 7 times 6, which is 7 times 6 plus here we have 6 plus R is 5. R is 5. So we can get 7 times 6, which is 42. 42 plus 5, which is 47. So they are equal. We can write like this. So this is for question number we can write this like this. And the other question we have another question. Let us see the next question of this example. A is 100, as we see. A is 111 and B is 3. So let us divide this by 3 first. A given number we have 100 divided by 3. We have to divide here 11 divided by 3. We get just 3 times 3 9. We subtract 9 from 11. We get 2 and we put here 1. We get 7, which is the same as it have no remainder, or the remainder is 0. So we get that Q is equal to 37 and R is equal to 0. We can write this A is equal to P is 3 into Q is 37. We can write here 37 and R is 0. So we can write like this. So our final answer will be, you can check from here. Yeah, we are correct. Let us do for the next question. The next question C. Letter C say that we can write this also in the form of A is equal to B times Q plus R. So let us see. A is 5, B is 8. So as this question is so we can write this like this. A equal to, let us write the question first. A is equal to 5. The B is equal to 8. We how to write in the form of B times Q plus R. We have to first divide 5 by 8. Let us divide by 8. We have that when we divide 5 by 8, 0, and the remainder is here. We have 0, we have 5, the remainder is 5. So we can write this equation. We get Q is 0. I can write like this, and R is which is equal to 5. So we can write this equation: a is equal to 0 into 8 plus 5. We can write like this. So this is the final answer for question letter C. You can check from this. This is all about. If you have any question suggestion, you can write your question or suggestion under comment of this video. I will answer or question you ask me on the comment with reply. Let us move to exercise 1.3. Exercise 1.3, for each of the following pair of number, let A be the first number in the pair of and the B is the second, and the Q and the R are each pair such that A is equal to B times Q plus R, pair 0 less than or equal to R and less than B. So we give it that the first is A, the second is B. So you can write this number in the form of A is equal to B times Q plus R. So we can write this in the form of, let us write the question first. We given number is say that 72, comma 11. This is the number. We will divide 72 by 11. When we divide, here is A and this is B, we can find Q and R from this equation. So 72 divided by 11, we can divide by 11. When we divide 72 by 11, we 6 and 6 times 11, 66, which when we subtract 66 from 72, we get that 6 when we 6, so 6 is less than 11. So the final answer is stop here. Here we have that get Q is equal to 6 and R is equal to 6. So they are equal. We can write this in the form of, so A is equal to, as we know, A B is 11, so we can write this 11 into 6 plus the remainder is 6. So we can, here we can put 6. So this is all about exercise. This exercise. Let us move to the second question. The second question will be, we can calculate in the form of A is equal to B times Q plus R. So let us see the question first. This is which is the same, but let us jump to C, and B is same as. Let us do B. The question under B says that 11. A is 11, B is 18. So this is more difficult than the first question. So we have to divide first 11 by 18. 18, here we have 18. Let us divide 11 by 18, which is 0. 0 times 11, 0 times 18, which is 0. When we subtract 11 from 0, we get 11. Then we have 11 is less than 8. We have to stop here, and we Q is equal to, 0, R is equal to 11. So we can write this in the form of A is equal to B is 18. So 18 is, sorry, not 8, 18. We have to write again. Here we have 18 into 0 plus 11. So this is the final answer for letter C. Let us do for the next question. The next question will be written in the form of like the first question. Let us see letter D or letter E. We can check. If you are not understand the other letters, you can ask me your question under comment of this video by subscribing our channel. Let us do D and E are the same. Let us do for E and let us do for E. Is E says that we have a given number uh, 176 comma 21. So this is a given number. Here A is 176 and B is 21. When we divide 176 by 11, we can use this with calculator, or we can uh, do with other form. Let us penny here we cannot, so let us use calculator and we can get simply you can use calculator to get this 160 divided by 21. We get that 8 is q, so 8 times 21 is equal to 168. So we can use this as 176 divided by 21. So we can 8 times 21 168, and when we subtract 168 from 176 we have 8. So 8 is less than 21, so we can stop here. We have that q is equal to 8 and r is equal to 8, the same. And we can write now this and we have b is equal to 11 21, sorry, 21. B is 21, so we can write a is equal to here we are r. So b is 21 and the q is equal to 8, which is r plus here 8. So this is the final answer for this question. And let us do for this final question for this exercise. The final exercise of this is very simple. We do under the same as we see, but let us do it. 25 and 39 are given as a given 25 comma 39. We have a given number. Let us divide. When we divide 25 by 35, we get 0, or q is 0. We can write again. Q is 0 and r is 25. We have a remainder of 25, so we can write in the form of a is equal to b times q, means b is 39. 39 times q is 0. Here we have put 0 and plus r is 25, so we can write like this. This is the final question for this exercise uh, exercise 1.30. So we move to the next lesson. The next lesson is Euclidean algorithm. We have given Euclidean algorithm. What is Euclidean algorithm? And we see in detail in this section with its exercise. Let us move to first with explanation. Find GSM of 60 and 36. As we know, GSM greatest common factor of 16 and 36 is, as we see before, we have a given number GSM of GCF, greatest common factor of 60 and 36 will be, we can as we know, this is 12. 12 is greatest common factor of 60 and 36. You can find this with with the previous question we do on our YouTube. You can find this from our YouTube by subscribing a channel. And when we divide the second question, divide 60 by 36 and find greatest common factor of 36 and the remainder. When we divide 60 by 36, the remainder is 24. As we know, when we divide 36, we get 1 and the remainder is 24. So again, you can find that the greatest common factor of 36 is that divide 60 by 36 and find the greatest common factor of 36 and the remainder of this. We have to here we have 36 and the remainder is 24. We get that again the greatest common factor of this 36 and the 24 is again 12. Again, divide 36 by 12. The greatest common factor of sorry for when we divide 36 by 24, the remainder is 12. So we can again find 24 greatest common factor of 24 and 12. This is the remainder when we divide 36 by 24. We get for this we have again the common factor of the greatest common factor of this number is again 12 is again the greatest common factor of this number. Again we will do with again common factor of when we divide 24 by 12, we have there is no remainder, which is we stop now here. So this when we compare all have the same common factor here 12 when we divide that number and we find the greatest common factor of that, we get the same. So such type of theorem is called Euclidean algorithm. So let us move to our theorem. Given if a, b, q, and r are a positive integer such that a is equal to q times b plus r, then the greatest common factor of a and b, which is as we see common 60 and 36, which a and b equal to the remainder of when we divide 60 by 36, we get the 12. The remainder is 24. When we find the greatest common factor of this, we get 12. So this is called Euclidean theorem. We see this with example. Let us do some example with this algorithm. So let us do again with this the same formula with previous question. እንግዲህ እንደምናያችሁት አንድን ቁጥር ለእንትኑ አካፍለን ሪሜንደር ነው ከዜሮ ውጭ ከሆነልን ዜሮ እስከሚሆን ድረስ እያካፈልን ከሄድን የምናገኘው greatest common factor of remainder in the greatest common factor of dividend in the quotient divisor is the same. So ስለዚህ አሁን ለምሳሌ እዚህ ጋር የተሰጠን ቁጥር አለ here we have as we given number 224. Let us not like this. Let us write with what is the greatest common factor of 224,84 with inspection with each other. Let us first divide. We can write here by finding a different formula. Let us do up to getting the remainder 0. When we divide this number by 24, we can use now calculator. to get the remainder of this number. 224 divided by 84. We can calculate without calculator, but as we see, 2 times 84, which is equal to 168. 68 minus 168 minus 224, which is equal to 56. So the remainder is 56. As we say before, the remainder of this greatest common factor of this in the greatest common factor of 84 comma 56 is the same as this. To get again, we can divide this by greatest common factor of uh, 84 when 84 divided by 36. The remainder is simply subtracting 80 from 84, 56, we get 28. So greatest common factor of 56 and 28 is uh, is 28. So simply we get uh, 28 50, because now we have to stop, because 56 divided by 28, the remainder is 0. So we have to stop here, and we can say that the greatest common factor of this is 28, and again with this inspection, the greatest common factor of this number also 28. So as the theorem, this is a simple form of calculating common factor of largest number. So this is all about this theorem. We do all example and with detailed description. If you are not understand this, we are writing, you can ask me or with under comment of this video, and I will explain the difficult question with detailed example, and you can easily understand the difficult question, and you are ask me your question with comment under comment of this video. So we move to now with exercise 1.14. Okay. So this is the next question for uh, this exercise 1.4. For the above example related directly, that we can calculate with different form with the greatest common factor. To find the greatest common factor, let us do for this. We have two. Sorry, let us select pencil. We have 4 and 84. To find the greatest common factor, as we know, this formula is better to let us divide each by 2 to when we you can to verify if they have the same or not. We have to check for this three greatest common factor. We have the first 224 and 84 are given. So let us first do this, and the next is we are finding for common. We divide this number by 2. When we divide this number by 2, we have here 11, 100, 114 and 112. Sorry, here are 112. 112 because 2 times 4, 2 times 1, 2, 2 times 1, 2. So this divided by 224 divided by 2, we get this. Again, we divide 84 with 2, we get 42. 42. We divide up to getting one of them prime number. So we divide now. Also, we divide this 112 divided by 2. We get 56. 56, I think 56 is 42 divided by 2. We have we have that's 21. 21. Again, we can also divide this number by 3. Uh, by 3, we get that when we divide 56 by 3, we get okay, by 3 it is impossible. By 3, this is not divided by 21 is divided by only 3 and 7, but 56 is not divided by 3. But 56 is divided by 7. When we divide it by 7, we get 8. So we divide it by 7. 56 divided by 7, we get 8. And 21 divided by 7, we get 3. So 3 is prime number. Now we have to stop dividing this number, and we try to get the greatest common factor of this. We have to multiply this number only. 2 times 2 times 7, we get that 28. 28. 28. So when we multiply this, we get that let us multiply 2 times 4, 4 times 7, 28. 28 is a common factor of this. Again, we can also show you can also show you for the next question. Let us show for 84 and 56. Here we have 84 and 56. 56. 56. When we when we divide each by 2, we can divide by 2. 84 divided by 2, which is 42, which is this 56 divided by 2, we get 28. Again, when we divided by this by 2, we get here we get 42 divided by 1. 2, it is 21. When we divide 28 by 2, we get 14. So again, we can divide this number with 2. It will be 21 is divided by 7, and the 14 also divided by 7. So we can write here 21 divided by 7, which is 3, and 14 divided by 7, we get again 2. So we get this is a prime number. So we can now stop and multiply this only the column of this. We 2 times 7, we get which is 28. So we can check all our 28 which have the same greatest common factor. So we again can do also for this 50. We given numbers that 56 and 28. 28 are given. So we can write here we can divide this by 2. We get that when we 56 divided by 2, we get 28 here, and here we have 14. Now also we can divide this by 2. 28 divided by 2, we get 14, and here we can again we can divide this by 2, we can get 7. Again we can divide this both by 7. 14 divided by 7, we get 2, and here we 7 divided by 7, we get 1. So now here we get a prime number that is not divided by both sides. So we can now stop, and when we multiply this down the column of this only, we can get 2 times 2 times 7, which is equal to 28, which is the same as the previous one. So we improve this answer with this formula. This formula is very good for sorry for finding greatest common factor in the least multiple of the common least multiple of a number, two numbers. So we can also do for 3 number. ሌተስ ይሄ እንግዲህ እንደምታዩት ቅድም እዚጋ ቼክ አድርገን 28 መጣቱ። አሁንም እያንዳንዱን ቼክ ስናደርግ 28 መጥቶልናል። ስለዚህ ቬሪፋይ አድርገናል ወይ ደግሞ ፕሩፍ አድርገናል ማለት ነው መምጣቱን። ስለዚህ ወደ ቀጣዩ ጥያቄ ነው የምናልፈው። ወደ ቀጣዩ ጥያቄ ስናልፍ find the greatest common factor of the following pair number by using Euclidean algorithm. So let us do for only selected question. Let us jump, we do A, C, E, only 3 from selected. If you have any question, you can leave your question that is difficult later on comment of this video, and I will try to answer all of you right question with replay. Let us do for letter A. Letter A says that the first letter A 18 and 12. So this is a given number. When we divide 18 by 12, we get 1, and the remainder is 6. So now we can find that 12 comma as we use we can find the greatest common factor using Euclidean. So we have to divide the given number, and we get the remainders, and the remainder and the divisor again find the remainder up to getting the remainder 0. ስለዚህ ምንድነው የምናደርገው ማለት ነው? እዚህ ጋር አሁን እንደተሰጠ እንደምታዩት 18 እና 12 ነው። 18 ለ12 እያካፈልን ሪማይንደሩን እና አሁንም 12ን እየፈለግን እስከ ሪማይንደሩ 0 እስከሚሆን ከፈለግን በኋላ ስለዚህ ያገኘነው ኮመን ፋክተር የዛ ቁጥር ኮመን ፋክተር ነው ብለን እንወስናለን ማለት ነው። አሁን ቀጥታ ወደ ጥያቄው እንዴት እንደሚሰራ እናያለን ማለት ነው። 18 ለ12 ስናካፈል ቀሪው ስንት ነው? 6። ስለዚህ 6 ብለን እንሄዳለን። አሁንም 12 ለ6 ስናካፍል ቀሪያችን 0 ነው፣ እንቆማለን ማለት ነው። ስለዚህ ኮመን ፋክተራችን እቺ ትሆናለች 6 ማለት ነው። ስለዚህ የዚህኛው 6 ነው ማለት ነው። እንደዚህ አድርገን መስራት እንችላለን። በጣም ቀላል ነው። ያልገባችሁ ነገር ካለ ጥያቄያችሁን በኮሜንት ላይ ጻፉልኝ። የፈለጋችሁትን ጥያቄ ተመሳሳይ ሆነ ሰርቼ ሪፕላይ አደርግላችኋለሁ ማለት ነው። ኮሜንት ላይ በጠየቃችሁን ኮሜንት መልስላችኋለሁ ማለት ነው። ወደ ቀጣዩ ጥያቄ ላይ ነው የምንሄደው። ቀጣዩ ጥያቄ ቢን እንዝለውና እስቲ ሲን እንስራ። ሲን ይሰራልን ካላችሁ ቢ ኮሜንት ላይ ጻፉልኝ። ከዚህ ውስጥ ያልሰራኋቸውን ጥያቄ የከበዳችሁን ኮሜንት ላይ ጻፉልኝ። ሰርቼ መልሱን ሪፕሌይ ላይ አስቀምጥላችኋለሁ ማለት ነው። ወደ ሲ ነው የምንሄደው። ሲ ላይ የተጠየቅነው ጥያቄ ምንድነው የሚለን 143 እና 39 የተሰጠን 143 እና 39 የተሰጠን የዚህን ግሬተስት ኮመን ፋክተር ፈልጉ። በማን በኢኩሊዲያን አልጎሪዝም የተባለው። ስለዚህ አሁን 143ን ለ39 ስናካፍል ስንት ይደርሳል የሚለውን እናያለን። መጀመሪያ 3 ነው የሚደርሰው። 3 ሲባዛ 39 ስንት ነው? 117 ነው። ከ143 ላይ 117 ስንቀንስ ስንት እናገኛለን? 143 መቀነስ ነው። በካልኩሌተር መጠቀም ትችላላችሁ። 26 ነው የሚቀረን ማለት ነው። 26 ነው። ስለዚህ ቀሪውንና አሁን የምናደርገው ቀሪውንና እዚህ 39 ደግሞ እንፈልጋለን ማለት ነው። ስለዚህ 39 the remainder is 26 when we divide 143 by 36 we get 3 and the remainder is 26. Again we are moving toward to divide 36 by 26. When we divide 39 by 26 the remainder is 13. So we move toward this 26 and find the remainder of, when we subtract 26 from 39 we get 13. So here we have greatest common factor of 26 and 30. We can divide 26 by 13. We get 0. The remainder is 0 because 2 times 13 is 26. So now we have to stop here in the greatest common factor of this number is 30, which is again with us Euclidean algorithm. This is also the same as the same common factor with this. So we have here 36. እንደዚህ የዩክሊዲያን አልጎሪዝም ተጠቅመን እንደዚህ አድርገን መመለስ እንችላለን ባጭሩ ማለት ነው። ተፈለግን ደግሞ እያንዳንዱን አካፋይ አውጥተን ከዛ ኮመን የሆነውን መፈለግ እንችላለን። እሱ እናንተ ፈልጉ። በዚህ መልኩ ግን ብትሰሩ በጣም ይቀላል ማለት ነው። አሁን ዲን እንዝለልና ኢን እንሰራለን። ኤፍንም እንሰራዋለን። የመጨረሻ ጥያቄ ብዙ ጊዜ ትንሽ ከበድ ይላል ይባላል። ስለዚህ ዲንም እንሰራለን። ሶ ኤፍን እንሰራለን። የመጨረሻው እንሰራላችሁ ያው ተለቅ ስለሚለው እስቲ ኢን እና ኤፍን እንስራ። አሁን ኢ ላይ የተሰጠን ጥያቄ የሚለው 85 እና 80 ሶሪ ዋይት ራይት እሺ ኢ ላይ ያለውን ጥያቄ ነው አሁን የምናየው። የተሰጠን ጥያቄ 85 እና 68 ነው። የዚህን ግሬተስት ኮመን ፋክተር እንድንፈልግ ነው የተጠየቅነው። ልክ ቅድም እንደሰራ ነው 85ን ለ68 ስናካፍል አንድ ደርሶ ቀሪ ስንት አለን? 17 አለን ማለት ነው። 17 አለን ማለት ነው። ምክንያቱም 17 እና 17 ሲደመር 68 85 ስለሚሆን ማለት ነው። ስለዚህ አንዳንድ ደርሶ ቀሪው ስንት ነው? 17። ስለዚህ አሁን ድጋሚ ማን እንፈልጋለን? የ68ን እና የቀሪውን ማለት ነው። የዚችን 68 እና ቀሪው 17ን እንፈልጋለን ማለት ነው። አሁንም 68ን ለ17 ስናካፍል ስንት እንደምናገኝ አራት እናገኛለን። ቀሪው 0 ነው። ስለዚህ የዚህ ቀሪው 0 ከሆነልን እንቆምና ምንድነው የምናደርገው? ይችኛዋን ግሬተስት ኮመን ፋክተር ብለን እንወስዳለን ማለት ነው። ስለዚህ የዚህኛው ግሬተስት ኮመን ፋክተር ከዚህኛው ጋር እኩል ነው በዩክሊዲያን አልጎሪዝም መሰረት ማለት ነው። ሶ we have remainder of greatest common factor for both 17. So this is all about question letter E. Let us find for question letter F. We move to F. Let us write first the question. The question says that 72, 86 and 16, 84. This is the given number. So we can find here greatest common factor of these by using Euclidean algorithm. When we divide this number 7286 by 1684, we get 4, and the remainder is how much we will see together. Let us multiply by 4 this number. We get 6736 minus 7286. We get 550 is the remainder under here. We can use a calculator to divide this because of large number. So 7286 divided by 1684, a given number, we get 4. Let us 4, then 4 times 84. When we multiply this, we get 6736. When we subtract from 7286, we get 515. So now we can find here the remainder. When we divide this number by this, and the remainder we get 1684 ኮማ 550 ሪሜንደር ያገኘነው ማለት ነው። ሪሜንደር ያገኘነው ማለት ነው። ስለዚህ አሁንም የዚህን እያካፈልን እናገኛለን። ምንድነው የምናደርገው? 1684 ሲካፈል ለ550 ቀሪው ስንት ነው የሚለው እናያለን። ቀሪው ስንት መሰላችሁ? 3 ይደርስና ቀሪው 3 ሲባዛ 550 ስንት ነው? 1650 ነው። 1650 ላይ እስቲ እንቀንሰን እናያለን። 1684 34 ይቀረናል ማለት ነው። ስለዚህ ቀሪያችን አሁንም የ550 እና የቀሪያችንን እንፈልጋለን ማለት ነው። እዚህ ጋር 34 አለን። አሁንም 0 እስከምናገኝ ነው የምንቀጥለው ማለት ነው። አሁንም እናካፍላለን። 550 ሲካፈል ለ34 እኩል ይሆናል። አጌን አሁንም ቀሪ ያለው ቁጥር ነው የመጣው 16 ነው። ስለዚህ 16 ሲባዛ 34 እኩል ይሆናል 544 ነው የመጣለን። ስለዚህ ቀሪያችን 6 ነው። የ34 እና የ34 እና ከ550 ላይ 544 ስንቀንስ 6 እንፈልጋለን ማለት ነው። 0 እስከሚመጣ ቀሪው እንቀጥላለን። የ34 ለ6 ስንት ይደርስልናል? 5 ቀርቶ ቀሪ 4 ነው። ስለዚህ አሁንም የ6 እና የ4 እንፈልጋለን ማለት ነው። ቀሪው 4 ስለሆነ ማለት ነው። አሁንም የዚህን ስንፈልግ የዚህም አሁን ቀሪያችን 0 አሉንም 0 እስከሚሆን ድረስ እንቀጥላለን። 6ን ለ4 ስናካፍል አንድ ደርሶ ቀሪ 2 ነው። ስለዚህ የ4 እና የ2 እንፈልጋለን። አሁን እናቆማለን። የዚህ የጋራቸው 2 ነች ማለት ነው። 2 ነው። እዚህ ጋር እንደምታዩት ስለዚህ this is 2 greatest common factor of this also 2, this also 2, for all 2 according to Euclidean algorithm. So this is all about exercise 1.14. If you have any question on this exercise, you can leave your question under comment of this video by subscribing a channel, and don't forget to share this tutorial for your friends. And if you like the video, you can hit like button, and for future you can also touch notification button for when I release the video, you can get notification. ስለዚህ ዛሬ ኤክሰርሳይዝ 1.14 እና 13 እንዲሁም ዴፊኒሽናቸውን ከነ አልጎሪዝማቸው ቲቶሮቹን እያንዳንዱን በቀላል መንገድ አስረድቻለሁ። ይሄ እዚህ ላይ ያልገባችሁ ጥያቄ ካለ ኮሜንት ላይ ጥያቄያችሁን መጻፍ ትችላላችሁ። ለዛሬ ይህን ይመስላል። ያልገባችሁ ጥያቄ ኮሜንት ላይ ጻፉልኝ። አስተያየትም ካላችሁ እንዳስተካክል የምትፈልጉት ነገር ካለ ኮሜንት ላይ ጻፉልኝ፣ አስተካክላለሁ። ለዛሬ ይህን ይመስላል። ቪዲዮውን ለጓደኞቻችሁ ሼር ማድረግ አትርሱ። እንዲሁም ሰብስክራይብ እያደረጋችሁ ቻናሉን መከታተል ትችላላችሁ ማለት ነው። በተለይ 9ኛ ክፍል ያላችሁ ልጆች የ9ኛ እንዲሁም ለኢንትራንስ ኤግዛም ለመዘጋጀት የምትፈልጉ ይህን የምሰራውን ጥያቄ በደንብ የምትከታተሉ ከሆነ ሁሉንም ጥያቄዎች በደንብ እንደምትሰሩ እርግጠኛ ነኝ። ሰብስክራይብ ማድረግ እንዳትረሱ። ቪዲዮ ከተመቻችሁ ላይክ አድርጉኝ። እንዲሁም ሌላ እንዲሰራላችሁ ኢንትራንስ ላይ ከዚህ በፊት የተፈተኑት ጥያቄ ካለ ኮሜንት ላይ አስቀምጡልኝ። ኮሜንት ላይ አይቼ ጥያቄውን ሰርቼ በሌላ ቪዲዮ እመለሳለሁ ማለት ነው። ቀጣይ የምናየው የ9ኛ ክፍል ማትስ ትምህርት የመጨረሻው ቻፕተር ኤክሰርሳይዝ ላይ ሚስለስነስ ኤክሰርሳይዝ ላይ የሚሰጡ ጥያቄዎች ወይ ደግሞ ሪቪው ኤክሰርሳይዝ ዩኒት 1 ሙሉን እያንዳንዱን በቀላሉ መንገድ እንሰራለን ማለት ነው። ከዛ ቀጥሎ ወደ ቻፕተር 2 ነው የምንገባው። አሁን ግን ነገ የምናየው ኤክሰርሳይዝ ሪቪው ነው። ሪቪው ኤክሰርሳይዝ ኦን ዩኒት 1 ፎር ማቴማቲክስ ነው የምናየው ማለት ነው። ስለዚህ ተዘጋጅታችሁ ጠብቁ። ቪዲዮን ሰርቼ እለቅላችኋለሁ። ሌላ ጊዜ እንግዲህ አንዳንድ ጥያቄዎችን ላይቭ ለመስራት እንሞክራለን። ላይቭ ይዘን እንቀርባለን ማለት ነው። ቻናሉን ሰብስክራይብ አድርጉ። እነዚህ ኪ ተርሞች ናቸው ለዚህ ቻፕተር። እነዚህን ሰመሪዎቹንም እናያለን በኋላ። በኔክስት የምናያቸው እነዚህ ናቸው። ሶ ቱዴይ ዊ ሲ ኦል ዚስ tomorrow we see a key term of this chapter in the summary. We also do a review exercise on this unit. We do all this question listed under a review question of unit 1. So subscribe this channel and wait for this exercise. For today, thank you. Have a nice day and wait for next tutor. Thank you very much.